Welcome friends. Myself Dr. M. Karthigaiselvi, Assistant Professor of Computer Science, the Standard Fireworks Rajantram College for Women, Sivagasi. Today we are going to learn inheritance concept in C++, which is one of the most important concept in object-oriented programming, which helps us to reuse the existing code and create a relationship between the classes, and this concept is widely used in real-time software development. By the end of this lecture, you should be able to understand what the inheritance is, identify the base and derived classes, explain the different types of inheritance in C++, and write the simple programs using inheritance. Inheritance is a mechanism where one class acquires the properties and behaviors of another class. Instead of writing the same code again, we reuse the existing class features. This improves efficiency and reduces the errors. And these are the basic terminologies that are used in the inheritance concept. The existing class is called the base class or parent class. The new class that inherits from it is called the derived class or child class. This relationship helps us organize the program logically. And this is syntax for inheritance. In C++, inheritance is implemented using the colon operator. The access specifier defines how the base class members are inherited. Public inheritance is the most commonly used form. And this is a sample example. Here the dog class inherits the animal class. The dog class can access the eat function from the animal class and also has its own function bar. This shows how code reuse works in inheritance. And these are the C++, it supports 5 types of inheritance: single inheritance, multiple, multi-level, hierarchical and hybrid inheritance. Let us look at them one by one. In single inheritance, one derived class inherits from one base class. This is the simplest form of inheritance and is easy to understand and implement. Then the multiple inheritance. In multiple inheritance, a single derived class inherits from more than one base class. Although powerful, it may lead to ambiguity, such as the diamond problem. If not handled properly, then the problem will occur. In multiple inheritance, a class is derived from another derived class. This creates a chain of inheritance, similar to a family generation structure. Next one is hierarchical inheritance. In hierarchical inheritance, multiple derived classes inherited from a single base class. This is useful when different classes share the common features. It's a hybrid inheritance. Hybrid inheritance is a combination of 2 or more inheritance. It is commonly used in advanced applications and often involves the virtual base classes. These are the access specifiers that are used in inheritance. Access specifiers that control how the base class members are inherited. Public members are accessible everywhere, protected members are accessible in derived classes, and private members are not directly accessible. This is the access specifier table. This table explains how access specifiers affect the inheritance. Notice that the private members of the base class are never directly accessible in derived classes. And these are the advantages of inheritance. The inheritance reduces the code duplication and improves the reusability, support polymorphism, and makes program easier to maintain. And these are the disadvantages of inheritance. The excessive use of inheritance can increase the complexity and make programs harder to debug. It can also create tight coupling between the classes. To conclude, inheritance is a key feature of object-oriented programming in C++ that helps us reuse code and reduce duplication. It allows us to represent real-world relationships in a structured way. By understanding inheritance types and access specifiers, we can design the efficient and maintainable programs. Overall, the inheritance, it plays an important role in building flexible and scalable software. Thank you for watching this video.